lecture series of basic electrical engineering. Now we are going to see the module 4. Module 4 is electrical utilities and production. So in this first topic of the module is different source of electrical energy and single line diagram of the power system. So this is our content of the module of today. So here we are going to see what is the necessity of electrical energy and why it is superior to all the forms of energy. So here we can come to a conclusion due to this following to the reasons why the electrical energy is preferred everywhere. So these are all the reasons. It is the convenient form of energy, it is easy to control, it has a greater flexibility and cheapness, cleanliness and higher transmission efficiency. Why are you going for this convenient form? Because electrical energy can be converted from one form to other form easily. For example, in case of you want heat energy, you can use a heater, because the electrical energy can be easily converted to heat energy. Similarly, if you want to control a motor, you can easily produce a mechanical energy. So it is a convenience form of energy. Second one is easy to control. For the same example, you can take the heater. If you want to control the temperature, you can control it automatically or manually. And also if you want to control a speed of the motor, you can control by using the voltage or current. Various methods are there. So it is very easy to control. Greater flexibility, so it can be generated easily and transmitted easily by means of a simple conductors. In case of mechanical energy, we require gear system or lengthier shaft. That problem is eliminated here. And cheapness, so it is very cheap for generation. For example, it costs for per unit energy generation is very less compared to other forms of energy. And cleanliness, so it is very clean because no fumes, no gases or no poisonous smoke, nothing will be there while generating while using this electrical energy. And also higher transmission efficiency. For the same power transmission through a conductor, it has a greater efficiency. So due to these reasons, we are going for the electrical energy. So what are the various energy sources? In general, we are going to see to convert. So here, first one is the solar energy. You know already, wind energy, geothermal, water is nothing but hydro, and similarly biomass energy. And saving energy is also one of energy resource nowadays. And also piezoelectric, that is also one more energy resource. And also here waste recycling, that is similar to the biomass. And similarly muscular energy, that is the human efforts. Due to human efforts also we can generate energy. Lightning, this is not quite possible, but we can use it in other forms because lightning is several thousand kilovolt. You can't trap it at easy moment. So these are all the various type of energy sources in which we are going to see the renewable energy sources. So what is renewable and what is non-renewable, that is also there. So here you can see what is the sources. So what are the sources? Source can be coal, hydro, nuclear, natural gas and petroleum. So these are all non-renewable energies actually. So later we'll be seeing the renewable energies. So how it is extracted? The coal is extracted by deep mining by means of, I think in Orissa Talchal is there, and in South India maybe Neyveli is there for generating this coal. And hydro cannot be it is from rainwater, you can directly get the source. And nuclear is also done by mining, maybe uranium, thorium or plutonium. Natural gas is also from oil and gas wells, and here petroleum is also same case. So how it is converted? So here you can see it is not ready to use. You have to do some processing. When the coal is extracted, it has to be processed, then purified, then you can convert it, and you can convert this into heat energy. For primary energy is actually coal energy, that is the steam energy. Then you can convert it into electrical energy. Then it can be generated as electricity. So this is the first form. Second form is hydro. Hydro, you can directly put it in a power station and make the turbine to rotate, and you will get the electricity directly. Nuclear energy, you have to do enrichment, and once again you have to put it in a nuclear reactor. Once again same steam energy, thermal energy, then power station, then you will get the electricity. In natural gas, once again, it has to be treated. Maybe a gas turbine has to be used, and to convert the electrical energy of the heat energy of the gas to electrical energy. Similarly, oil well. Here we can get the crude oil. In that we have to refine it. We have to do many process in that. Fractional distillation, you will get LPG, petrol, diesel. Many you will get in that. Once again, any form of energy once again converted into very particular engine. For example, petrol engine or diesel engine or LPG, that is gas turbine. We have to convert into the mechanical energy. Then once again it is converted to electrical energy. So here we are talking about more about electrical energy. So here we are using only the generator. That is the only difference. Electrical generator we are using for the primary energy. We are using these much sources. Maybe heat energy to steam energy, or here in nuclear also heat to steam, in hydro direct potential energy to kinetic, kinetic to electrical energy, and similarly in natural gas same. So it is first chemical energy, then it is further converted into heat energy, then it is converted into electrical energy. So mechanical and electrical. So primary is first we have to transfer the energy. The only energy transformation is done by these various resources, and converter here is the electrical generator. But the resources are from different areas. So in this we are going to use what is the global energy used by the sources. So maximum about 60.8% in the world we are using the power generated by means of the coal, and remaining is the nuclear. So nuclear is a little bit dangerous because the radioactive disposal and act of terrorism will be there, so we are using less. Then third one is climatic dependent, that is hydro. Whenever the rainy season is there, we can generate more uh, water, so that through the water you can generate electricity. And the next one is the renewable. Now we are moving towards this one. So solar, wind, biomass. So this is emerging trend. So I think almost we are getting success in it. But some factors are there that is deep to the subject. We'll discuss later. And also some natural gas also it is processing. For example, biomass and also gobar gas, and many gas power plants are there. Due to that, we are getting some 8.54%. This diesel is used very less. In case of emergency, we are using it nowadays. So what is a commercial energy and what is a non-commercial energy? So energy resources that are available in market for definite price, known as commercial energy. So and this can be from commercial energy as electrical, coal, refined petrol. It's the same. So these are all the very good example. What is non-commercial energy? So it is not available in commercial market, and the price is not classified. For example, firewood, agro waste, uh, solar energy. These are all known as non-commercial. It doesn't have any pricing, standard pricing in the global market. So that's why it is known as non-commercial. So we are going to speak about the renewable energy. So this is also one more type of non-commercial energy, in other words. And also one more word we can use is this is the non-conventional methods. We are converting into the conventional methods nowadays. The renewable energy is obtained from the source that are essentially inexhaustible. It is always available, and also this cannot be diminished within years. So like coal, approximately for 30 to 40 years we can survive with the coal. Later it's a question mark, but we always have the wind, we have always have the solar, geothermal, tidal, hydroelectric. So these and all so coming under the category, and also this biomass energy is also, and this will not release any harmful pollutants in the form of smoke or in the form of hard waste. That is the beauty of the renewable energy. So now we are classifying the renewable and non-renewable energy. So as I discussed already, renewable. So these are not all the renewable. So biomass is nothing but the plant waste, animal waste, everything. And next one is the solar. It is from directly from the sun. And this one is water. This is directly from the rain. Then wind. Due to unequal heating of earth, we will get the wind always. And geothermal due to the magma below the ground. It is non-renewable. So oil, as I discussed already, oil and coal, or we can survive for some these three. We can take natural gas also. These three are dependent on time. So approximately scientists have proved that only 30 to 40 years we can survive with the coal. That's why we are looking for the alternative, that is the renewable, and also nuclear. So nuclear also around 20 to 30% is available as of now. So it is a time to switch to the renewable energy resources. So here we want to see about the world energy consumption also. So which field is consuming more of the energy, whatever may be the energy. So here the industry sector is more everywhere. So around 51 in international level, around 29 in national level, around 25 in state level. These consumes more energy. Then transport, already fuels, so electric trains, so every that is the second category. And domestic, for all the domestic purposes we are consuming the energy. Here in the world level it is little bit very less, but national and state level it is more compared to the others. But also commercial level, for all the commercial buildings we are consuming 7.8 for international level, 9 for national, 70. And for others, some other purposes such as small scale and all, you are using national level as 5% and state level as 8.4%. This is just a number. You want to remember where the utilization is more. The utilization is more in industrial sector compared to the other sector, but in the state level it is for domestic. That is for residential purpose, it's more. That comparison we have to remember. So now what are the advantages and disadvantages of energy resources we will see. So fossil fuels, that is coal. So what is the advantage? So it is generated electricity always depend on coal more, and it is easy to transport, and it can byproducts also it can be used for making other products. But what are the drawbacks of it? It is non-renewable. Burning produces smog, we know that, and also the coal releases some substance called NOx and SOx, which is very risky to the atmosphere, and also risk of oil spills. So these are all the disadvantages. Next one is nuclear. So very concentrated. One pellet can produce energy about 1 gallon of petrol. One pellet is similar to our one medicine tablet. Okay. So this do not produce any smoke. That is also one more advantage, but produces radioactive waste. The waste disposal is very, 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 very risky. If you bury under the sea, also it is very risky. If you bury under the land, also it is very risky, and it is non-renewable. Radioactive elements cannot be reused. Solar, so it is very good energy. Now people are depending on it. Government is also giving incentive for that. It do not have any air pollution, but it is very very expensive. The PV cells are very expensive, and used only in the equatorial region where the sun is more. It can't be used in the poles. That is the drawback. Water is always renewable and pure and clean. It does not produce any air pollution, but you have to disturb the ecosystem by constructing the dams, and it is a long term process for construction. That is the drawback of it. Wind energy, it is renewable, it is relatively inexpensive and does not produce any air pollution. Only possibility or only drawback is, so it can be utilized where the guard section is there. That is a I may seen about many passes. Wherever the passes is there, there only we can install the windmills. Otherwise, the windmills we can't install everywhere. Next one is the geothermal. It is also unlimited source. It is available in the middle of the earth, so we can suck it from the earth. But it requires more land for it. The only drawback is uh, it has more hotspots. That is, you can see somewhere you can get the smoke due to the geothermal activity, and also its wastewater can damage the soil. That is the byproduct can damage the soil. But biomass is renewable, and it requires large area of farmland and produce smoke. That is the drawback of it. So we can see one by one in individual. We know that solar energy resources. Today we are speaking more about it. This is a modern residential also we are seeing it is getting from the sun. Sun is nothing but what is the name of it? Photovoltaic. It is nothing but sun's energy and produced by light. Voltaic is electricity. So light is converted into electricity by chemical reaction. So the range of the PV cells will be from 30 watts to 300 watts. It is a DC. So we have to use an inverter to change the DC to AC in order to usable form, because universally we are using AC more. So we have to convert it, and we can give it to the electrical grid also. So here you can see that is the sun. So from the sun we will be getting the solar panel. From the solar panel we are getting the inverter. So inverter is used to directly send the voltage to the battery. Once again, the battery is utilized here to convert the DC to the electrical panel, and once again it gives to the home, and we can give it to grid also. Here you can see in the morning it is only given to the morning, it acts as a input, and the night it acts as a output. So here you can see energy is saved, and in the night the energy is utilized from the grid as well as from the solar panel. So this is about the solar panel. So the light energy of the sun is converted to electrical energy by means of this solar panel. Then once again it is used by charge controller to charge in a battery. In the night time it is utilized by means of the same inverter. It converts AC to DC, and it can be more abundant power is there. We can send it to grid also, or you can utilize in your home also. So this is about the solar energy. Other solar energy application, it is used for heating and cooling of residential buildings. Solar water heating we can use. Now it is quite popular. And the solar drying of agriculture and animal products, that is also used. Dryers, solar dryers, now we speak about. And it is used for evaporation of seawater in salt production, especially in the seashore areas. Solar cookers, it is well known, we might have studied in your physics also. And solar engines for water pumping, that is quite possible. Solar refrigeration, then solar electric power generation that we are going to see, then solar power voltaic cells. So there are two methods. One, by heating the water, and we can convert the heat energy to steam energy, then electrical energy. That is also one more method, but widely used is this method, that is solar photovoltaic cell. This is also one more advantage. And solar furnace for heating purpose in industry. So these are all the basic advantages of solar energy. Next one is water energy, and in terms of technically it's known as hydropower. Hydropower is nothing but utilizing the kinetic energy of the falling water into mechanical energy. The generator once again converts the mechanical energy from the turbine into electrical energy. For example, we can store the water in the dam, so it is nothing but the potential energy. The potential energy from high level to low level, it will produce a kinetic energy half mv square, that is going to hit a turbine and produce a mechanical energy. That mechanical energy is transferred as electrical energy by means of electrical generator. There are various type of grids: microgrid, mini grid, micro hydro grid, hydro generation, and mini hydro generation, like that. So micro can be used in our homes also, and we can have a giant dams like Hoover Dam that can produce electricity for million people also. That is also possible. Micro, mini, and macro. So this is about the hydropower system. So here you can see. So this is a simple power plant structure. Here you can see this is the dam. Here water will be there. This will be the penstock. Here the water will be having the uh, mgh, that is the potential energy. When it is flowing through the penstock, it produces half mv square, that is kinetic energy. The turbine will be placed here. This turbine, and thus kinetic energy of water will be hit on the turbine to produce the mechanical energy. The turbine in turn is connected to the electrical generator. This electrical generator generates the power and steps down, and through the transformer and transmission line it reaches our home. So the wastewater is given to the trial race. So this will be the basement. So this is known as the head race, and this is known as the tail race. So this is the process of converting the water energy to the electrical energy. So next one is the wind energy. Wind energy is the one of the most popular and recent trend renewable energy. So today it is today and tomorrow also it will be used. It is a clean, non-polluting electricity we can get from it. It is unlike from conventional power plants. It does not emit any air pollutants or greenhouse gases. It is quite clean and it does not rely on fossil fuels or natural gas, etc. On NOx and SOx, or that is nitrous oxides and sulfur oxides, are not released. But only thing is we have to install the power plant where the wind energy is available. So it is operated by lift and drag force. So here you can see this is the lift force, this is the drag force. So you can see the wind flow. If the wind flow is like this, we have to get the lift force and drag force. So both the forces, which is topic of aerodynamics, in which the flight is working. When the flight is running, what will happen? The straight force is known as the drag force. It has to take, while taking off, you can see the lift force. From the ground level, it will be taking off. Same principle is utilized in the windmill. So the only one point we have to install the windmill in the pass area, that is between two mountains. So here you can see the windmill is rotating. So what is inside the windmill? So how we are getting the power generation, that will be seen in the next slide. Before that, want to see how the wind is produced due to unequal heating of earth. So nearby sea area means the land will be heated more compared to the sea. So from the hot water from hot air from the land will move towards the sea. Sea has a cold wind that will be moving from the cold area to hot area. Heat transfer. Due to that heat transfer, a pressure difference is created and wind will be produced. That wind is utilized for the power generation. So what is inside the windmill? So here you can see. So the windmill can rotate like this, and this also can be rotated. This is known as pitch and yaw control. So this is known as the yaw control. This is known as the pitch control. Turbine blade can itself rotate along according to the wind direction. So this is known as the blades. This is known as the rotor. This is the pitch control, as I said already. This is the yaw control. This is the moment, and there's the tower, there's the controller and generator. As usual, this wind energy produces the mechanical energy of the turbine. This is converted to shaft. Here a gear drive will be there. Here, for example, if the wind turbines rotate one time, the gear will rotate 100 times. In turns, it is connected to the generator. The generator produces the electrical power. Here control is required. For example, abnormal wind, the turbine should stop. So many, for many conditions it is useful. So if this yaw control is according to the wind direction, the head will move. So for that purpose, this yaw control. This pitch control is for braking, or we have to control the wind speed. For example, if wind speed is more, we have to produce a braking force so that it will rotate and it will produce a braking force. So this is about the wind electricity generation. Then from here it will go to control room, where we can control the electrical power, either generation or transmission. Next one is a very important form, that is the geothermal energy resource. Geo itself, geographic, thermal, heat. So geothermal energy is heat from the earth. So this heat is recovered as steam or hot water, and used to heat building or to generate the electricity. So it is a natural energy flow within the earth depths. So geothermal energy is localized in particular points, not everywhere, where the geo heat is utilized to heat the surface water or steam or something, and we will be getting that by drilling the pits. So we have to drill the pit along a particular direction to certain kilometers, then only we'll get this geo heat, that is geothermal, that is used to heat the steam. So here you can see, so hot water springs due to geothermal from the earth. So this is the earth. So where the geothermal energy can be placed for the electrical power generation. Similar to the volcano explosion, that is quite natural. Here we are producing it as an artificial form. How it is produced in the artificial form? Here you can see this is the magma. It is the more it has more temperature and more pressure. So if you want, we can put a steam vent here so that we can get the hot air. This hot air is used for geothermal generation, and we can store it also, and we can transfer it also according to our utilization. So this picture will give you a more clear view about it. So here this geothermally heated water is sucked out, and it has to pass it to other heat exchanger. From the heat exchanger, the steam is converted. Here the brine water we are using, it is nothing but the salt water. It is once again exhausting in the steam turbine. So steam turbine will produce the mechanical energy. These mechanical energy is converted into electrical energy and transformer and transmission lines. Once again the used water is recycled in this form, so that once again it is recycled. So there is a cycle of the process. This is the closed loop system of the geothermal energy. Next one is a tidal. So it is also the energy obtained from the hydropower. It is from the sea. The tides are produced due to the gravitational force from the moon. So that it is also not predictable. We can hear that during the full moon day, the tides will be more. No moon day, the tides will be less. Same principle is utilized. So here, due to the tides, we will be constructing a dam. So here you can see this is the dam in the sea. So when the tide is high, it will be moving in this direction, while moving inside this dam or the wall. Here you can see a turbine which can be rotating from this direction, so that we will be generating the power. In case of low tide, what will happen here? The level will be less. Here the level will be more. The water will be going out, so that the power is utilized for generation. So here you can see a little bit clear view. So this will be the barrage or a dam. Here it will be the sea. Here the watermark will be more, so the water flow will be in this direction. So between the land and the sea, we will construct a dam, so that the tide power is used, but it is not uniform power. It has more drawbacks also, and it is limited in generation structure. Next one is the biomass. It is an uh, organic this thing is used, that is waste is used from the plants or the animals. It is a renewable source of energy. So it is stored and it is dried, and then the biomass is burned, then it is converted to chemical energy. Once then the chemical energy is converted into heat by means of boiling the water. The same steam is utilized to convert the steam energy. The steam energy once again convert to mechanical energy by means of turbines. The turbine is utilized to generate the electricity. So this is about the biomass. The various type of biomass are wood fuel. We can see this everywhere, especially in rural areas. Then rubbish waste or whatever the waste will be, maybe uh, waste which is disposed outside. Then alcoholic fuels, that is also there, and crops, dried crops, and landfill gases. These sound all are the types of biomass energy. So a little bit clear, you can see this here. Though, so human waste is utilized, solid waste from the municipal, animal residues, then industrial residues, forest residues, all are utilized in the form of biomass energy. This biomass energy produces the fuel, that is maybe in the form of heat. Once again, this heat is converted, and once again the gas is cleaning. Once again it is given to the combustion chamber. This may be a gas, or this may be a solid, whatever it may be. It will be converted to the combustion chamber. The combustion chamber in turn produces the heat. This heat in turn converts the water into the steam. The steam is converting into mechanical energy by means of turbines. The turbines is connected to the electrical generator, where we'll get the electrical energy. Here this can be utilized once again. It can be recycled many times, but it produces the polluted gases outside. That is the drawback in it. So this is the schematic diagram of biomass energy. So non-renewable. So what are the other energies? So non-renewable energy, it is from conventional fossil fuels such as coal, and you can see the oil, okay, and also gas. So these are all non-renewable energy resources, which is likely to be depleted within a stipulated time. There is a chance of reduction of this energy. So that's why it's known as non-renewable energy. How we are utilizing it. So whatever it may be, same process similar to the biomass here. Maybe nuclear fission or nuclear fusion takes place and heat may be generated. Coal is burnt and heat may be generated. Natural gas is burnt and heat may be generated. And and also oil or maybe petroleum products are burnt and we'll be getting the heat. This heat is utilized in boiling the steam. So here we are placing the water which is boiled by means of this heat source. So this is actually the non-renewable source. So all the methods are same. Only the process is different, but same process, sorry, same principle is carried over everywhere. So heat is produced. The heat is responsible for converting the water into steam. There are three stages of steam. One is the wet steam, dry steam, and superheated steam. Superheated steam will be having high temperature and high pressure, and it is made to exhaust on a turbine. So the heat energy and the pressure energy produces the force on this turbine, which in turn converts the mechanical energy on the turbine, and turbine will starts to rotate, and the water may be recycled once again. The turbine is coupled with the electrical generator. The generator will produce the electrical energy as usual we know. Then once again it is stepped up by means of the transformer to increase the voltage level to reduce the losses. Then it is sent for the transmission and distribution by means of electrical towers, and once again it is stepped down through our transformers, and we will get the energy for utilization. So this is the non-renewable energy process. So one thing we have to keep in mind, so up to this it is a different process according to the type of fuel. After that the same process is utilized. So this is about the non-renewable energy. So the next part of our topic is power system. So we told that in many forms we are generating the electricity, but electricity is generated by means of a generator, but the energy resource used are different. Based on that we classified it in many ways. The generating station generates the power up to one level. So it may be generating up to 11 kV. Once again, it is stepped up by means of the step up transformer. So here you can see the red color is on the generating station. All the generating station, if you go to any generating station, for example, hydro, thermal, everywhere, will have this setup. So in this only low level will be generated. It will be stepped down to maximum level. For example, 765, 500, 345 kVs, kilovolt. So 11 kV will be generated, and it will be stepped up to 138 kV or 230 kV for transmission. So because to avoid the transmission losses, once again this is known as the transmission lines. So which is in the blue color. This is the transmission part. Once again it comes to the one more transformer. Here step down process will happen. We might have studied the transformer in the module 3. Same we are utilizing here. So here you can see it is step down. So step down may be around 120 kV or 240 kV according to our use. So here 138 kV is stepped down to 28 or 33 or 66 kV once again. And once again it is given to the distribution. Here you can see the distribution that is in the green color. So here it may be some 26 or that may be bigger consumers. For example, 33 kV will be getting by the industry directly. And for our residents, here one more transformer will be there. Here that 11 kV is stepped down to 440 volt, which can be placed by ourselves. So here you can see 26 kV to 69 kV. These and all consumers. This black and all coming under consumers. They will be using only 26 kV or 16 kV. Second type of primary consumers will be using 13 kV or 4 kV, maybe 11 kV also. Finally, secondary consumer, that is we will be using either 230 volt or 440 volt or 120 volt. So in India, we are not using 140, 120 volt, we will be using 240 and 440 volt. Based on this, we are deriving a diagram which is known as the single line diagram. So the same diagram, here you can see generation, transmission, and distribution. So this can be done in this way also for engineering purpose. So it is very difficult to draw all these structures. So we are drawing it in a single line diagram. Single line diagram is nothing but in one line we are explaining all. So I told already. So this is the symbol of the generator. Maybe one sine wave may be putting. So this is known as the generating station. Here we may be generating 6.6 kV or 11 kV or 10.5 kV, 38.8 kV, or this is the rating of the generator. It is stepped up in a sending end substation. So this will be in the generating station. Here we will be stepping up to 11 kV. So 11 kV will be the generated power. It will be stepped up to 220 kV or 132 kV. or 110 kV also, 440 and 765 is the maximum level, and it is transmitted to the conductor, so which we might have seen in that previous diagram in blue color, that is the transmission. Then it reaches the receiving substation. It is also one more transformer. Here it is once again a step down transformer. Here the 220 kV is step to 33 kV or 66 kV. So based on the utilization. So this 66 kV or 33 kV once again is transmitter, that is also coming under the secondary transmission. So these two are known as the primary and secondary transmission. There once again it will reach the secondary substation. So in the secondary substation there is one more transformer. Here it will be stepping down the voltage to 33 kV to 11 kV or 6.6 kV. So this is the secondary substation. Here sometimes the 11 kV will be directly fed to the industrial customers. For example, big industries, colleges, commercial complex will receive this voltage. This is known as the primary distribution. And once again, one more transformer. You might have noticed this in the roadsides. We'll be having one transformer, that is 11 kV transformer. So this is the secondary distribution. In that distribution, step down transformer will be there. It will step down to the level of 11 kV to 400 volt. If in case of three phase, so in apartments and all, we will be having this for 11 kV bar 400 volt transformer, and roadsides also will be having that three wire system will be there. In case of single phase, we will be getting 230 volt for a single phase, one phase and one neutral we will take. So this is the last consumer, that is the end consumer, that is V. So this is the travel history of the electrical power from generating station to the consumer. So this is simplified in the single line diagram, but if you draw it as an engineering diagram, it will be carrying more time and more content in it. But for our understanding, we are drawing it in a single line diagram. So here you can see the low voltage level. What is meant by low voltage level? It is below 1000 volt. So system is AC, that is the secondary distribution, that is we are using 230 volt, 440 volt. So this is the end consumer. Next one is medium voltage level, that is 1000 volt to 69 kV, that is AC. That is the primary distribution, that is the industrial consumers, big commercial buildings, big colleges. So they will get the same voltage, that is the primary distribution. High voltage level is below 100 kV, that is kilovolt, that is also in the form of AC, that is a secondary transmission. Here only the transmission will be happening, no consumer will be utilized. You can see big towers while traveling in the highway, that will be coming under this category. EHV, that is extra high voltage level, that is 230 kV to 800 kV. Now the DC is also coming into picture. So AC and DC, this is also primary transmission. This also you might have seen in the roadsides. UHV, that is the research now going on many places. From Dehradun they have installed it, but not in our areas. So but it is in research. So 800 kV to 1000 kV. Here the one problem is the designing of insulation. So this is coming for both AC and DC. This may be using for primary distribution. So these are all the, so we are seeing in bottom up approach. So this is the final end user. This is the first point of generation level. So this is about the single line diagram of electrical power system. Thank you for watching.